This is my math homework number 11, Wednesday. For the first one, it says, which equation has the same unknown value as 3.48 minus something equals 0.53? Now, you could do the math if you like, or you could do my strategy. In my strategy, we don't really need to find out the answer. We just need to figure out the ones that have the same equation. So what I like to do is like to round. So for example, I'll make this guy into a 3. This guy, I'll leave blank for now. On this side, 0.51 I'll make into a 1. So I know this one will be a 2. Because 3 minus 2 equals 1. And I can also change colors. For example, watch this. I'll make this one into a green. So all I need to do is now replace every 3.48 I see with 3. So this is a 3. This is a 3. This is a 3. That's a 3. And I'll change every square into a 2. That's a 2. That's a 2. That's a 2. That's a 2. Lastly, I'll change everything that I see, well, everything that is 0.53 into a 1. That's a 1. That's a 1. This one doesn't even make sense. That's 0.63. That's a 1. Now I just need to do the math for each one and see which one makes sense. Which one is 3 minus 2 equals 1. The first one works because that one is 3 minus, well actually, yeah, that one is 3 minus 1 equals 2. That one works. For the second one, you can't do 2 minus 1 to give you 3. So B does not work. C obviously doesn't work because it's supposed to be 0.53 and instead it's 0.63. That one's wrong. And the last one is going to be 1 minus 2. That doesn't make sense. You can't do 1 minus 2 equal 3. It has to be 1 plus 2. So that one does not work. So the only one that's logical and works is going to be the letter A. 3.48 minus 0.53 equals 2. So what I did is I just put a number with every decimal and I put a certain color to it. And anytime I see that number on my choices, I put the 3 or the 2 or the 1 instead. And I just found the one that matches it because the first one is 3 minus 1 equals 2. And that one's exactly the same thing as mine. 3 minus 1. Or this one is 3 minus 2 equals 1. This one's just reverse. 3 minus 1 is 2. So that one works. For the second one, it says, which equation shows a correct strategy and product for the expression shown? So this is going to be 5/10 times, that's 6/10. Because those are tenths because you have only one digit behind the decimal and you have the 1 0. So for the first one, 5/10 times 6/10 equals 30/10. That one's going to be wrong because I know that 5 times 6 is going to be 30. And it'll be 2 numbers behind the decimal, so it'll be 0.30. So the way you would write that would be 30 hundredths. So the first one is wrong because that's supposed to be 30 hundredths, but instead it's 30 tenths. For the second one, it's 5/10 times 6/10 equals 30 hundredths. That looks good. For C, it's not 5 hundredths times 600, so that's wrong. And D is once again is not 5 hundredths times 600. It's 5/10 times 6/10, and it gives you 30 hundredths. So the correct answer would be the letter B. For the next one, it says, Kenny took his sister to the store. He uses the model below to help her understand how they spent money at the store. So every large square that you see represents one whole dollar, and every small square is 25 cents. So before the store, they had $1, $2, $3, $4, $5, and 25 cents. So $5 and 25 cents. After the store, they had $3 and 75 cents. So that's our math problem, really. You have 5 whole dollars before you went to the store, or before Kenny and his sister went to the store with 25 cents. And then after the store, they had $3 left with 75 cents because you have 3 of the small squares, and every small square represents 25 cents. So all we need to do is do our math problem of $5.25 minus $3.75. I'll go ahead and write it over here so we can see better. So I know that 5 minus 5 will be 0. I need to break down the 5, or you can use the word borrow, or you can use the word decompose, and that makes it a 12 minus 7, which will give me 5. So we know it will be 50 cents back so far. And 4 minus 1, or 4 minus 3 equals 1. So Oh, well, so we know that they spent $1.50 at the store. And we can prove that by adding $1.50 with the $3.75. That's how much they have left after the store. And it should give us the $5.25 back. So that's going to be our answer, $1.50. Moving along, it says true or false. Well, this is 0.09. You have two numbers behind the decimal. That's going to make this guy the same thing. So we have 1, and then we can add 0, 2. So now we have 9 hundredths on the left side, and we have 90 hundredths. So that will be a false statement. It should be the other one. For the very last one, it says enter the number that makes the equation true. So we have 13, and all of these are 13. I noticed that as a pattern. And this is the starting number, the 6,732. And all these, when you add them all up, it should give you that 6,732. So let's go and add what we have so far. So we have 6,300 plus the 30 over here and plus that 2. That gives a total of 6,332. Now all we have to do is subtract that from your 6,732, the starting amount. Here it is. 2 minus 2 is 0. 3 minus 3 is 0. 7 minus 3 is 4. So we know that square must be a 400 out of 13. So that missing square can be figured out by adding what you have already and subtracting it from what you started it with. And we knew that the square has to be a 400.